For this example, we're again going to take a spray gun calibration, but we're going to use a liquid fertilizer in which we're not provided a level of application in fluid ounces per unit area, but instead we're going to decide what the application level of the nutrient is, and we're going to determine how much fertilizer we need based on what this material weighs. We have a 1500 liquid fertilizer, and it weighs 11 pounds per gallon. Okay, so it's 15% nitrogen by weight. It weighs 11 pounds per gallon. We've decided that we're going to apply it at a half pound of nitrogen per 1,000 square feet. We can deliver a spray swath of 8 feet, and we have a 100-gallon spray tank. So we're going to set up our calibration calculations very similar to some others that you've seen in these practice runs. If we take a desired goal in sprayer calibration is 1,000 square feet. So we take 1,000 square feet, divide it by our spray swath, which is 8 feet, and we come up with 125 feet is how long our course test length needs to be. We've also talked quite a bit about an appropriate speed, and we've said that it's pretty standard to target 3 miles per hour. 3 miles per hour is the same thing as 4.4 feet per second. Okay, we have 125 feet course length divided by 4.4 feet per second. We would basically need to cover this length to go 3 miles per hour in approximately, and that's what I'm going to do is round this number off, about 28 seconds. And why this matters is that this is how long that we would collect the sprayer output in order to determine the volume of spray solution being delivered per 1,000 square feet. For this example, what I've done is I've just selected a sprayer output that is 255 fluid ounces, and that is a realistic number that would be collected. 255 fluid ounces has been collected, and that's per 1,000 square feet. Let's convert this to how many gallons this would be per 1,000 square feet, and remember there are 128 fluid ounces per gallon. So if we take 255 divided by 128, the answer is it's right on 2. It's 1.99. And what I'm going to do is just round it up and say that is a delivery of 2 gallons of spray volume per 1,000 square feet. Okay, so that's what our sprayer will be calibrated to deliver if we keep our speed constant and our pressure constant as we're currently set up. This spray gun is delivering 2 gallons of solution per 1,000 square feet. Okay, now we've got a 100-gallon spray tank. How much can we cover with a 100-gallon spray tank system? So if we know that the delivery rate is 2 gallons per 1,000 square feet, let's proportion this out to a full spray tank, which is 100 gallons, would be to some unknown X square feet. And again, in working with proportion, units on the top must match. Here they're both in gallons. Units on the bottom must match. Here they're both in square feet. And don't worry that the unknown happens to be on the bottom side of this proportion, because all a proportion is going to do is either enlarge or shrink the relationship between two variables. So we cross multiply, divide, and solve for X. Work our way through this. We have 2 times X equals 100 times 1,000, which is 2x equals 100,000. Now we're going to divide both sides by 2. And we end up with x equals 50,000. And remember, the units that we are solving for are back over here in the proportion, square feet. So 50,000 square feet. And that's how much a full sprayer tank can cover. Okay, now the only additional step that we need to do compared to our other calibration examples that we've conducted is we must work with this weight on a pound per gallon basis. This material is 11 pounds per gallon. It's 11 pounds per gallon, and its analysis is 15%. So it doesn't matter if it's liquid or solid, because the fertilizer analysis is always on a percent by weight basis. So 11 times 0.15 equals 1.65 pounds of nitrogen. And remember that the 11 pounds is how much it weighs per gallon. So we have 1.65 pounds of nitrogen per gallon of 1500. All right, how much nitrogen are we anticipating to apply? And we look back up to our givens, and we are targeting a ½ pound of nitrogen per 1,000 square feet. That's our goal. So we want a ½ pound of nitrogen. Let's set up another proportion. 0.5 pounds of nitrogen is to 1,000 square feet. And if we're making up a full spray tank here, it would be X pounds of nitrogen is to 50,000 square feet. Okay, so we have 50,000 times 0.5 equals X to 1,000, and this number turns out to be 25,000 equals X to 1,000. Divide both sides by 1,000 in order to solve for X. X is equal to 25, and remember what the units are: pounds of nitrogen, right? We need 25 pounds of nitrogen in which to cover 50,000 square feet in order to deliver a level of a ½ pound of nitrogen per 1,000 square feet. So we need 25 pounds of nitrogen. Now we go back and look at this number, which said there's 1.65 pounds of nitrogen per every gallon, per 1 gallon. Let's proportion that to 25 pounds of nitrogen is to how many gallons? That's my unknown. Again, we cross multiply, divide, and solve for X. 1.65 times X equals 25 times 1. Let me correct that. Okay, we divide both sides by 1.65. Always helps if you can talk and write at the same time. Try this one more time. 1.65, and 25 divided by 1.65 equals 15. And what's the unit? It's gallons. It's gallons of 1500. 15 gallons of 1500. And this is how much fertilizer of the liquid would be added to the spray tank. The spray tank would be brought up to 100 gallons total volume. And if your speed and pressure stay the same as it did in your calibration run, you would then be delivering a ½ pound of nitrogen per 1,000 square feet.